It was 6 years ago that Airbus officially took over the aircraft program that was the Bombardier CSeries, a fuel-efficient and drop-dead gorgeous new narrow-body. That aircraft is now known as the A220, and it forms an important part of the Airbus product lineup. Today we're in Mirabel, north of Montreal, Canada, where the CSeries first came to be, to see the impressive facilities that Airbus have developed here, from the final assembly line to the flight test development center and even the paint shop. There's a lot to see here, so we're going to be splitting things into a couple of videos. But let's get into it, everything you ever wanted to know about how an A220 gets brought to life and sent into the skies. It should be a fun one. Welcome to Mirabel, the Airbus production facilities where they're making the A220. This aircraft that, if you've watched this channel for a while, you'll know I'm a big fan. It's so cool to come here where it all started, of course. So here you have various aspects of the production process, and we're taking a look at the pre-FAL, the pre-final assembly line, and the final assembly line here that's below, just back there, as you can see. And it's just such a cool thing. Anyway, we're checking out all about the A220 line up here in Mirabel today and tomorrow. We're gonna see all kinds of stuff. And then after that, I'm gonna fly down to Mobile, Alabama to see where the other final assembly line for A220s is down in the US, in Alabama. So that should be super interesting. Get a sense of what's going on all over in the North American Airbus production. So let's go around today, Mirabel. We've got some great people showing us around, see what happens here, what it's all about.
Yeah, as you can see, you get that major component, that mid-fuselage, which is coming from China. It's equipped with tubes, pipes, but no insulation. It's pure structure, which comes from overseas, and that is equipped. Equipped means fitted with an insulation blanket, with wire harnesses, with equipments, in a way that it is completed, tested, and then delivered to the final assembly line, either in Mirabel or the final assembly line in Mobile. So that's why we call that section here the pre-FAL, which is a pre-final assembly line. So we do equipping of our major components, big fuselage sections. It comes from overseas by sea freight, by normal, especially containers. It comes from overseas, then it gets trucked by road from the port, from the nearest port to Mirabel. And then when it's equipped, obviously from here to the next side of the building, it's very easy. But when it's going to Mobile, it's also trucked on a special transporter on the road.
Wow, the road all the way down.
All the way down the road. So here we are at the heart of the pre-FAL, the pre-final assembly line, where we equip our sections with harnesses, with insulation blanket, adding the equipment and testing it. You see two big sections, which is the rear section and the mid section, or the rear fuselage and the mid fuselage. The forward fuselage and the cockpit comes from our sister company Airbus Atlantic in Canada, which is about 2 kilometers away, and all gets merged into the final assembly line. It's a new building, a new industrial setup, which was designed taking benchmark and with our pre-final assembly lines from Europe, from Toulouse, from Hamburg, where Airbus has gained some experience on making that. So all that came into here, and we have built a super efficient pre-final assembly line. To some extent, it protects the final assembly line. Every work of customization means specific adaptation of harnesses for a specific aircraft configuration. One customer has a different cabin than the other customer. Behind that cabin are wire harnesses, tubes and pipes, and they have a slight different configuration. All that is happening here, which allows us to make decisions of custom allocations and customization requests pretty late in the process, and do that right here before we transfer the fuselage, equipped fuselage, to the final assembly. That streamlines, that de-risks and allows more flexibility than doing that very much upstream. Imagine we would do that when it's done overseas in China or in the UK or somewhere else. It just, decisions will have to be taken much earlier, means the customer will have to decide much earlier. And here we are now having an advantage of doing that later, more flexible, right before the final assembly. You can see here in that example of the up fuselage where we have a part of the aluminum, the metallic fuselage joined with the carbon fiber section. That white area is a carbon fiber section, and obviously that joint, that's where the loads come together, where the dynamic and static loads come together. That's where the rear pressure bulkhead, that's where engineering is at its core. The fuselage of the 220 is mainly built out of aluminum. Means the cockpit, all the fuselage up to the rear pressure bulkhead, it's done by aluminum. The aft area, the non-pressurized areas, the vertical and horizontal stabilizer, as well as the wings, large wings, these are all done in carbon fiber composites, built in different stages of the production flow. Center wing box, where all the loads go through from the wings into the fuselage, that's also carbon fiber material with some titanium reinforcement, titanium, as we call it, the titanium blankets of cruciform, which go where loads are transferred into the different parts of the section. So what you see here is how that industrial flow works. Each fuselage section comes on what we call a trolley and moves every tack, depending how fast we're going. The whole line moves. It moves on those rails, and when it comes out at the end, it's fully equipped, and then it gets transported into the transportation SAS, where it gets prepared for transport either to Mobile or the final assembly line next door. But it is something which has been proven to be very efficient, because these line movements, they happen overnight when it's less workload, and when we restart operations in the morning, all the line has moved, and the operators can go to the same pace, to the same working area to execute the next aircraft. Here's a good example of how the section comes from our partners out of China. It's a non-equipped section. You see the bare structure with the stringers, with the frames, and on the left side you see the end result of the pre-final assembly line, which is a fully equipped. You can see the insulation blankets, wire harnesses, equipment, tubes and pipes installed, and that's how we deliver the sections then to our FALs. Moving these big sections with cranes, obviously, into those trolleys, and once they're on the trolley, they remain on the trolley until they get out of the pre-FAL, as they're tacted every now overnight to the next station. This is this part, and this is where the fuselage sections come from the pre-FAL. See here the sections, and that's the station 1 where they get assembled as a fuselage as a whole, and station 2, which is what we see right here, and station 3, what we see right there. Here we are at the start of the final assembly line. You can see over there the mid fuselage, which is now fully equipped, which came from the pre-FAL, is positioned there, and then we start what we call the station 1, which is the orbital joint of the fuselage. We basically create from a set of sections a fuselage completed, and that happens on those stations. We have in this building we have 2 final assembly lines, 2 lines, line 1 and line 2, and they're working in the same way. It's the same working structure, the same drawings. Actually, the same aircraft comes out. So, starting with station 1, it's what we call the orbital joint. Once that fuselage is completed, it is moved by crane into station 2, what we see right here. And you can see, you appreciate already wings being assembled, horizontal stabilizer, vertical stabilizer being assembled, and landing gear is integrated. So the aircraft moves out of station 2 on its own wheel. It gets dropped on his own wheel, and it moves to station 3 on his own wheels, with a wing installed, with a vertical horizontal stabilizer. It actually looks like an aircraft. Then it moves in station 3. Station 3 is where the aircraft becomes alive. That's where we switch on the power. Electrical power, hydraulic power, pneumatic power. That's where we do the first functional checks of the aircraft, making sure that the electrics are integrated, it's working, everything lights up, the fuel is tight, there is no leakage. All that happens in station 3 before the aircraft moves after that into cabin furnishing, engine integration, and paint job. And then afterwards we go into delivery. This industrial system is set up for delivering rate 14. Rate 14 means 14 aircraft per month. So we're going to rate 14 in 2026. As a whole, is a 1.4 million square foot in the size, and we do have around 3,500 people working on this site. These are all functions which a program needs. So it is starting from the engineering, the design engineers, the program managers, the manufacturing engineers, production, delivery team, paint shop, up to the customer services. So we do have the customer response center, which is a 24/7 operations supporting the customers, also in the side of Mirabel, who is who are supporting our customers in their in-service activities. Glad to ask you to sign that banner for us as well.
Oh yeah, amazing.
As any special guest.
Anywhere you want.
Here we are in the completion, what is cabin integration. So we integrate all the cabin of the different customers, being it business class, economy class seats, galleys, lavatories, ceiling panels, hat racks. Everything is integrated here. And on top of that, this is the position where we integrate the engine. So the engine is produced by Pratt & Whitney next door, and then it's transported over here or to Mobile. And that's the position where we install the engine. And after that, the aircraft gets prepared for its paint. So that's where it gets the external livery later on. But the aircraft for that, of course, needs to be closed. Closed means engine integrated, wing to body fairing closed, all the panels closed, everything completed so that the aircraft can get this nice finishing.
So when it leaves here, it's ready to fly, except that paint, no?
Now, when it leaves here, it goes into paint shop. After paint, we've got the final test to the stage what we call FOT, which stands for fully operational and tested. And that is the moment when the aircraft actually is completed and tested. And after that milestone, which is a formal milestone, which is reviewed with our flight test organization, with quality, with the authorities, so again, now the aircraft is good to go into a flight test campaign. So proudly I can present, this is what's going to be our new delivery center. That's an extension of the site of Mirabel. We've built 2 more positions for a delivery center. That's where we're going to operate all the deliveries with our customers in the final stage before they take the aircraft. That's where the physical deliveries, that's where the correction of any customer requests are happening, but also that's where the commercial transaction is going to happen before the customer leaves his brand new plane. So welcome, now we are in flight line, or what we call the customer line. So the aircraft is now returned from the paint shop. It has completed all its final checks and has been transferred from the production system into the flight test system and delivery system. That's what we call the customer line. The aircraft will start its auxiliary power unit, it will run its engines, it will get prepared for its first flight. So then the flight test team will take over the aircraft and perform the first flight. They will do all kinds of flight profiles, driving the aircraft beyond the envelope which would be applied in the commercial operations. Once the aircraft returns from the flight, the production team will take over, will correct any snags which were in flight, up to the point where Transport Canada, the authorities, will issue the certificate of airworthiness. That's basically the certificate that the aircraft is completed, it's airworthy, everything has been done as per design. Then the delivery team takes over. Customers will arrive with their pilots, with their cabin customer acceptance team. They will then go on that plane, do the customer acceptance flight. So that means the airline pilots will fly the aircraft, will do all the checks on either off the cockpit. They will do cabin checks. They will do any cabin tests, make sure that the cabin management system, the bins, the doors and the lavatories, the galleys, they all work. After that, the aircraft lands. Any customer snag, customer request is being corrected. While that is completed, the aircraft goes into the commercial transaction. That's when the commercial delivery happens. And after that, the customer goes into the aircraft and flies away with a brand new A220. So here we are in the heart of the customer line. So you see the aircraft is completed. It's getting prepared for doing its first flight. So you see engines are open. That means the maintenance work to prepare the engine, to run the engine is being done. The last rigging of the doors, everything is being checked and validated. Make sure here the flight controls are all deployed. They're all inspected for last time before the aircraft actually takes off for the first time. That's what we call the pre-flight inspection. It's the most important one, because after this, our pilots will go on the plane and fly away.
You were telling me that you use Flight Radar 24 not only for fun but also professionally in terms of monitoring the delivery and acceptance flights, things like that. Could you tell me a little more about that?
Yeah, I do use Flight Radar, so it's on my app, it's on my phone, and I have to say I use it every day. I use it private, personally. When I'm at home and I see a aircraft flying over, so where is that going? And by now I basically know all the flight schedule. But more important, I use it also professionally because I do monitor with that. I know where our aircrafts are. If I say our aircraft, it's either our production flight aircraft or customer flight aircraft. I can monitor the flight envelope, the speed, the height of the aircraft. So, and based on the flight profile, how it has been achieved, I know if the aircraft has a good flight or if there's some rectification to done afterwards. So that tells me a lot, and I keep monitoring that here in Mirabel and in Mobile, and it's actually pretty fun and very, very useful.
Nice, that's awesome. We love to hear that kind of thing. We're now in the part of the production process where aircraft are pretty much ready. They've been painted. There's one over there in particular that I wish I could show you right now. It's such a cool version of the A220, and it's one that I really want to fly at some point. A very interesting airline. I can't show you, it's tantalizing. I want to shoot it, but once we can reveal that one, hopefully, or once it gets revealed, hopefully we get a chance to actually fly on it and see what it's like. But this Air France one, quite common around Europe now, looking gorgeous. It's my preferred way to fly around Europe. Short haul business class, this thing is hard to beat for sure. These sections of fuselage wrapped in blue out here are the ones that have come from China. I'm told that's how they arrive before they're put into the processes here. Really cool. They come here on a ship and it takes a few weeks and they go through the whole process once they're here. They come empty basically and then they leave equipped, right? You said it was equipped.
Yeah.
These are not equipped.
These are not equipped.
And then afterwards they become equipped when they leave here. Great.
Welcome to Mirabel. We want to call it the home of the A220. This is really, the site is really built around the program. It has really all the capabilities. So that serves the program from the design, with the design office, of course the operations, the production, but also the customer services. We support our customers, the fleet that is now in the range of 350 aircraft in service, also from that site. So yes, in essence, that site has all the competences, all the professions, and all the jobs of an aerospace company. It's like a mini Airbus, if you wish. And we want to keep it that way because we think it's also a matter of serving the product and serving our customer in a very efficient way. It's been 6 years that Airbus has now invested in the A220 program, and really what we've tried to do, what we want to do is first make sure the program is on solid feet. So that's obviously consolidated the fundamentals, making sure that yes, production can be ramped up to what we believe is really efficient. So we target 14 aircraft per month at the horizon of 2026. Volume is important, because also first our customer, the demand is high, but also it's with volume goes economies of scale, and this is what we need also to make sure that the program is on solid economic feet. We are building the capability further. We have also now flight test capability. Production we used to have, but also development flight test capability here that allows to support any evolution of the plane and flight test the aircraft and then certify the modification, an important decision. What we want is that program to be given the means to be a real market leader and also at a certain point in time to grow further. The platform has a lot of potential, so we want to be ready if and when the time comes when the aircraft can be evolved, potential stretch version of the aircraft can be developed. We need to be ready, and that goes with the means, the people, the processes, the tools. This is also what we are preparing now.
This is the Customer Response Center, the CRC, for the A220, and in here they're monitoring every A220 aircraft that's out there in the world. What's especially cool to see is that they have flight radar up there using great use of the filters, where you get the A220s that are across the globe on a big screen. I kind of wish I had that in my house where I could filter out certain aircraft types and just see them big like that. Anyway, they're monitoring over 350 aircraft. That's how many are in service right now. Many more on order, so that's interesting. It'll be a growing bunch of yellow aircraft icons on that wall, and they're addressing every single problem that might come up for customers around the world, also a growing customer base. So pretty impressive how quiet and calm it is in here, considering all they have to do to ensure that this worldwide fleet of over 350 aircraft is operating smoothly around the world on a daily basis. Really cool to see inside this sort of thing.
This is the A220 Customer Response Center. This is a space where specialists and engineers are co-located, working 24/7, all year long, aligned to one single goal: to provide technical solutions to our customer with high quality, timely, so they can return their aircraft to service. So here's where the team is established. So a bit of what do we do, right? The Customer Response Center is the entry point for all the A220 operators around the world to receive customer requests, on-site support requests, all type of requests with all type of priorities. So here at the CRC, we also try to work on 3 different fronts. One is a reactive front, where customers are coming to us with their questions and we try to respond to them. There's also the proactive part. We have access to all the parameters provided by the aircraft if the customers allow us. You know, the A220 is capable to report close to 51,000 parameters in real time, and if we have access to that, we can help the customers to troubleshoot or to identify proactively some failures. And lately, we have implemented a predictive model. Using the data that the aircraft is reporting, we have now 9 active algorithm models to capture events before they actually occur, which is anticipating a potential technical delay or AOG for customers. The aircraft is reporting the data, coming to an algorithm model that we have studied and that we measure the effectivity. So what happened with that? When that comes to us, we issue alerts to customer telling them this valve has not been open at 100%, for example. It's at 99, so we can predict that in 20 flight cycles this valve is going to fail. So we recommend you to replace the valve, or to maintain the system, to perform a test, etc., depending on the algorithm we have.
One of the things that we use flight radars like almost every day, every time that we have a customer calling for AOG situation, first thing we do, we validate the status of those aircraft. So if we see the aircraft is still not flying anymore, then this aircraft will be prioritized as this aircraft is now AOG for us. So myself for parts, if parts are required, and Juan Pablo for service, that will be the priority for us on that day.
That's all we have time for in today's video, but there's much more coming up in the next one, so make sure to subscribe to the channel and turn those notifications on, because next time we're going to be back with a look inside the paint shop. We're going to meet a test pilot who's been with the program since the very beginning. We'll go see the flight test development and meet the Iron Bird. If you don't know what that is, you'll soon find out. We'll even check out the cabin of a JetBlue aircraft that is pretty much ready to go. And we'll hear all about everything that goes into making sure a cabin is compliant with regulations and certified with all safety considerations taken into account, alongside, of course, the passenger experience. There's even going to be a part 3 where I try flying one of these things in a full-motion simulator from taxi to takeoff and back to the gate in Zurich. So make sure to stay tuned, and thanks for watching so far. In Mirabel for Flight Radar 24, I'm Gabriel Lee.